Hello again, dear students. We are still reviewing the different forms of equations and how to solve equations in different cases. And this is actually the third and the last one in this topic. Let's review quickly the steps used for solving equations. If we have variables on each side, we start by simplifying the expression. You might need to use distributive property. So you simplify and you might use distributive property. And then the second step is using addition or subtraction property to isolate the variable. And again you simplify. And the last thing, using multiplication or division property. As introduced earlier, we said it's opposite to the order of operation in simplifying expression. In solving equations, addition and subtraction comes before multiplication and division. Let's start by warm-up using geometry application. You might need to recall some formulas you studied earlier, like in the previous tutorial. We reviewed the area of parallelogram, which is height by base. Now it requires to review the area of a triangle. You might pause the video and answer this following question. Let's see what do we have. It's required to find the value of h so that the figures have the same area. So we have two triangles. In order to have the same area, you might write an equation and solve it to find h. As I explained earlier, if it's required to write an equation and then solve it, half the credit is for writing the equation and half for the solution. In case of a multiple choice question like this one, as in standardized tests like the PSAT or the SAT itself, if you have the equation and you have a multiple choice question, you might consider the direct substitution rather than solving it. And this is the approach which you would find in the PowerPoint. But now, for me, I'm going to write the equation and solve it by the steps introduced earlier. Let's first recall what is the area of a triangle. The area of a triangle is half the base times the height. And actually, in right triangles, you either use this one as base and this one as height, or both of them, or this one height and this one base. It doesn't make a difference. For this triangle, this is the base, clearly this is the base, and this is the height, and the height is h minus 2. So let's find the area of the first triangle. Half the base, which is half the 6, because we said earlier the base can be 6. So half the 6 is 3 times the height, which is unknown, and it's required to find it actually, is equal to the area of the second triangle, half the base, which is half 10, 5, times the height. And as we said earlier, the height here is not the h, it's actually h minus 2. This is the whole height, that's why I have to use brackets. So again, the area of the first triangle is half 6, which is 3 times height h, half of the area of the second triangle, half the 10, which is 5 times the height, which is h minus 2. To make both of them equal, this is the equation I wrote. Writing this equation now, I have to solve it I have to simplify it in order to solve it. I might use distributive property here to distribute the 5 over the bracket, so the left-hand side remains the same. 5 times h is 5h. 5 times negative 2 is negative 10. Now I have two variables and one number. As introduced earlier, put all the variables on one side. To avoid having negative signs with the variable, drag the smaller coefficient to the bigger coefficient. So I'm dragging the 3h to the 5h with opposite sign, and I'm dragging the negative 10 to the left hand side. So in the right hand side I have 5h minus 3h. On the left hand side I have the negative 10 with the opposite sign, which is positive 10. 5h minus 3h is 2h equals 10. Now divide by 2 to cancel this 2, so h is equal 5. You might check your answer by substituting in the original one by 5. I would use another color to check. I would check here. In the original equation I wrote first 3 times 5. I'm asking myself, is it equal to 5 times 5 minus 2? 3 times 5 is 15. 5 minus 2 is 3 times 15. It is also 15, so it is correct. So the answer is h is equal 5. In the PowerPoint presentation, which is uploaded on your drive, you might find another approach. As I said in the beginning of the video, if it's a multiple choice question, you might use direct substitution for all the answer. You might use h for 1. You only write the equation and use replace h by 1 once, and replace it by 3, and replace it by 4, and replace it by 5 until you find the correct answer. Again, it's your turn. Try to write the equation and solve it to find the value of x. But this time, try to recall the area of a rectangle. Correct, you guessed it correctly. The area of a rectangle is length by width, or base times height. This is the base and this is the height. This is the length and this is the width. Both are vocabulary for the same sides of the two sides of the rectangle. And the base and the height of the triangle, if we consider this is the base and this is the height, because in right angle triangles, both the legs, anyone can be the base and the height. So the area here, let me remove this so you would be able to see the figures clearly. The area here is the length times the width, so the area of the rectangle is 6x, while the area of the triangle, half the base times the height, half the 4 is 2 times the height is x plus 4. Again, I'm repeating, in right angle triangle, any of the two legs can be the base and the other can be the height. It doesn't make any difference. Half the 4 is 2 times the height, which is x plus 4. This is my equation now. You solve it for x, you should start using distributive property. The left-hand side as it is, 2x plus 8. Now drag the smaller coefficient to the bigger one. I still have the 8. 6x minus 2x is 4x, is equal 8. Divide by 4, x is equal 2. Again, you might check by substituting x for 2 in the original equation, in this one. So 6 times 2, and do this, write this question mark over the equation, over the equal sign, because you're asking yourself whether x verifies the equation or not. And 2 plus 4. Again, 6 times 2 is 12. 2 times 2 plus 4, which is 2 times 6, again 12, so it is correct. So your answer is correct. And this is the beauty of equations, that you can always check your answers. Now let's see the objective of this tutorial. Previously, we learned how to solve equations with variable on each side. We learned special solutions and how to simplify with grouping symbols. Today we're going to solve equations for given variables, and those equations called literal equations. Literal equations are equations involve not only one variable. It might have more than one variable, 2 or 3, and you're solving for one of them. You're solving for a particular or a given variable. And we're going to see how to apply this in real life problems, and it's a very good application for science problems. The first example here, he's asking me to solve 5b plus 12c is equal 9 for b. What does it mean to solve for a specific variable? It means to isolate this variable, to keep it by itself on the left-hand side and everything else on the right-hand side. So to solve an equation for a variable, it means to isolate, to completely isolate this variable. Let me write the equation here, 5b plus 12c is equal 9. First of all, we always start by addition and subtraction as introduced earlier. So I would drag this 12c to this side by the opposite sign. Now I have 5b is isolated but not the b. 9 minus 12c. I still have the 5 is attached to the b. The 5 is still multiplied by b, and I need to isolate this b. So to undo multiplication, I would divide. To undo multiplying by b, by 5, I would divide the other side by 5. So this 5 would be taken to the other side as division. So b will be 9 minus 12c divided by 5. And this is really important. You're not only dividing the 9 by 5, you're not only dividing the negative 12c by 5, you're dividing the whole right-hand side by 5. To isolate b, so in order to make b completely isolated, you will drag this 5 to the right-hand side as division. It means you're dividing the whole right-hand side by 5. And this is how we can isolate b, and this is what we mean to solve it for b. b is totally isolated by itself on the left-hand side. It's your turn now. Pause the video and then check your answer. It's required to solve it for y. Let's write the equation here. 2x minus 17y equals 13. And it is required to solve it for y. Again, to avoid having negative signs, I would prefer to drag the negative 17y to the right-hand side while dragging the 13 to the left-hand side. Why do I have to do this step? It's not necessary. I'm just doing it to avoid having negative signs with the variable I need to isolate. And as explained earlier, it doesn't make any difference whether the variable on the right-hand side or the left-hand side. So let's do this step. 17y, and in case of having the variable on the right-hand side, we always read the equation from the variable. So it is 17y, and I still have the 2x, and I would bring the 13 with the opposite sign, which is negative 13, to the 2x. Now I can use a property called a reflexive property. This property, which means I can just reflect them. I can just swap them. It would be written as 17y equals 2x minus 13. I did nothing. I just made the right hand side on the left hand side and the left hand side on the right hand side. They are still equal. 2x minus 13 is equal to 17y, exactly similar to 17y equals 2x minus 13. Now the last step to isolate the y is to get rid of this 17. As in the previous example, 17 is multiplied by y. To isolate y, I would divide the whole right-hand side by 17. The 2x minus 13 is all divided by 17. Which answer is this one? It is C. Now let's see a harder example now, but it's very important for real-life application, especially in science. If I have an equation involve more than 1x and it's required to solve it for x, the same variable which I'm solving for, the specific variable, is repeated in the equation. Let's see what to do. The first step must be done is, since it's required to solve it for x, put all the x's in one side. So I'm rewriting it. Having this negative x plus y, xy, negative xy would be dragged to the left-hand side with the 7x. And of course, don't forget to change its sign. And after taking the negative xy, I still have the 4 as it is. And now I will bring the negative 27 to it with the opposite sign. Again, let's recall what is done here. I'm repeating this step for you. And I need a larger space. What is done here, that this negative xy is dragged to the left-hand side. So 7x plus xy. And after taking the negative xy, I still have the 4 on the right-hand side. I dragged the negative 2z, which is plus 2z, to the right-hand side. So now I have the two x's on the left-hand side. What can you notice about the x? The x is called here a common factor between those two terms. What does it mean, a common factor? It means it's multiplied by 7 and it's also multiplied by y. So I can just factor it out. This x, which is multiplied by both 7 and y, can be factored out. And this is actually like the inverse operation of distributive property. We had one term multiplied by a sum or difference, and you multiply it by each one. Now, if it is multiplied by each one, you can factor it out. Again, it's the inverse operation of distributive property. You may check whether it's correct or not. If you multiplied x by 7, you get 7x. If you multiplied x by y, you get xy. So this is called factoring out. Factoring x out. Because it's a common factor. It's multiplied by 7 and also multiplied by y. And still, the right-hand side remains the same. Why did I do this step? I did this because I need to isolate x. And x now is multiplied by this expression, which is 7 plus y. To isolate x and get rid of this multiplication, I would drag it to the other side as division. And in one step now, I can isolate x completely by dividing the right-hand side by 7 plus y. Again, I needed to solve for x, so I need to isolate x. So the right-hand side, 4 plus 2z, is all divided by the expression multiplied by x, which is 7 plus y. And that's it for today. Until we meet again. Assalamu alaikum.